vs. Griffiths E&M section 2.5.3 surface charges and the force on a conductor. In general, we know that the force that a charge feels can be related to the magnitude or the value of that charge and the electric field that it sits in. What about the force that a conductor feels? Okay, so let's go ahead and draw a conducting piece. Okay, so I will draw it like this. This is my conductor. I know that the electric field inside is equal to 0, one of the rules of the conductor. And I also know that the electric field outside, immediately outside of my conductor, must be equal to sigma over epsilon naught n hat. All right, and that's going to be perpendicular to that surface n hat right there, the unit vector. Okay, so there are some charges that may or may not accumulate on the surface, and that will determine what that electric field looks like. So now what about the force? What is what force does this conductor feel? All right, we have a force. Instead of talking directly about a total force, we'll say a force per unit area, little f, that is going to be equal to our charge density, sigma. Right, I'm making this parallel between this expression up here. And now we have to figure out what electric field to use. Right, below the surface, the electric field is 0. Above the surface, the electric field is not necessarily 0. Which one do we use? Well, there's a complicated argument that Griffiths goes through, but it essentially is that you're going to take the average of those two electric fields. So I'm going to take the average of my above electric field plus my one inside. In the case of our conductor, we know that the electric field inside is equal to 0. And we know that our electric field outside has a particular form too. I guess this should be a vector here. F is equal to then sigma over 2 times sigma over epsilon naught in the n hat. Okay, I'm going to rewrite this in a way that is not entirely obvious why you would do that. Epsilon naught over 2 sigma squared over epsilon naught squared. What I did is I added an epsilon naught on top so I could square it on the bottom. N hat. And hopefully you recognize this right here. What is that? That is just the square of our electric field outside. Right. So I know the magnitude of that force is equal to, wrong Greek letter, epsilon naught over 2 times the outside force, or outside electric field squared. This is a force per unit area, so this is a pressure. And Griffiths calls that an electrostatic pressure. So if you know the surface charge density, often due to induced surface charges on a surface of a conductor, you know what the electric field looks like, right? If you know what the electric field looks like, you know the force that those charges are feeling. And therefore you know the pressure, the force per unit area that conductor feels.